think, yeah, by way of introduction, has been introduced. I have my first degree in electrical engineering. Then I did masters in electrical engineering in Nigeria, a university called Bamidele University. Then I have my masters in mobile communication at Lancaster and PhD in the same university, it's the same unit. While I was doing my PhD, actually, there was this joke we used to crack that I wrote more proposals than I papers as a PhD student, because I was in this group where our professor was he's an Iranian professor, top professor. But he has a business, he has a big company. It's just like this WINLAB. Everybody that finished his PhD with him, they moved to this company and he started paying them. Very, very great man. So as PhD student, he kind of filter you through. There's a filter. If you are very good, you get to one side. You're not good, you become a proper PhD student. And his good is measured by how many proposals and the way you can present and business, more of business. So while I was doing my PhD and many proposals, I kind of extended my PhD. I actually stayed a bit longer than usual. Then I wrote this FP7 project, which we didn't get the first time, I think in my third year. When we wrote it, then we tried the next time, and we actually won 15 over 15, the highest score you can ever get in European project, 15 maximum point. It was about smart metering today it's no longer new, but at that time it was the hot topic, 2007, 2008, very hot. So we won that grant, and I led one of the work packages where we deploy smart meter. But using specifically, what was unique at that time was not just smart metering, but the fact that we're using narrowband PLC, power line communication, instead of wireless. That's what we did. We deployed in Israel and also Hamburg, with two big utilities across Europe and then in Israel. So when I finished my postdoc, after 3 years of postdoc and everything, I went straight to lecturership. I moved from Lancaster to Manchester Met. And that takes me to, so this is broadly my area, and you will see why in a minute. At the heart of what I do is embedded system, like most of us, communication system. They are kind of applied to various areas. Actually, when I go to Lancaster, so these are some of the projects I've worked in. I won't go into them because I'll be talking about them. But when I got to Manchester Met, my first grant, interestingly, I think I've tailored my talk more to application, not core science, because I see that this is more applied environment, and I know that there will be many PhD students or academics that would want to see academic in a different way. So when I got to Manchester Met, my first grant actually was with Jaguar Land Rover. Again, it's a bit slightly outside of my area, but I did beamforming algorithm for microphone inside the car called F-Type car. It's a very tiny car, but very expensive sports car. So they were having problem with noise cancellation and so on. So that was my actually first grant. Again, not communication system as you will find it. Then one day somebody kind of rang into the university and asked for somebody with experience in smart metering. And then they called me, and I got there, and after the talk I realized it wasn't smart metering for electricity, it was actually smart metering for water. I was nearly going to say no, but eventually I thought, well, water, electricity, the core of it is smart metering. So I accepted it, and actually over 3 years, I made more money in water, smart technology for water, than I've made in my own field, if you like, which is connectivity, embedded system, intelligence system for water management, which I think kind of made a lot of sense to me after. And because I work in water, most of the things that I'll be talking to you about today will be about building, transport, energy, and all of them, they are kind of connected one way or the other. That's where last year when I got my professorship, so I became associate professor about 2.5 years ago, and last year when I wanted my full professorship, I was given professor of smart infrastructure, because instead of being a communication guy, which was my background, I actually applied communication system to divergent area that you can broadly call infrastructure. So this project, what I'm excited about is that I actually completed, I signed up, this was the last thing I did before I boarded plane 2 days ago. this project. It's about standpipe. You might not know it, but it's an interesting thing. You see, this pipe, anytime you see people building a new site in the UK, it's around the world, but in the UK, if you have to build a new construction site, you need something to go under the hydrant. It's called hydrant, a manhole, to get water out. Shipyards, they use it to get water from the hydrant into the ship. If you're washing like tall buildings in the city, to get water to actually start washing windows around cities, you need this. So this is something people use in tapping water, natural water from the ground. And most times they don't pay for it, which is like stealing water because they make money but they don't pay back. So government is kind of cracking down on that, and they started asking them to use meters so that you know how much water they're using and so on. So they've been using mechanical meter for a while, and they make a lot of money by renting this out, so they came to us to kind of turn this to a smart system. So we'll be able to do that, you know, various systems where we have staff working on it, and over the past few years we've come to a much better product that when you have this now, this was the prototype when it wasn't smart enough, like the prototype, but now it's really very smart. I'll show you an example of what we have. So anyone who is using this now, any part of the world, we know the location, we know the water that you're using, we probably know who is using it. And it's beginning to, things that the water utilities never thought about before is beginning to come up as a result of that. So we have an embedded system in it that gives a lot of information about the water network. And we can see it through the, you know, the usual Google map. So where we've, like I said, this is one of some of this company actually was worth about, I don't know in dollars, but in pounds, a very small company, worth about $300,000 when I started this project with them. We have not sold one single unit. We've only given maybe about 40 or so to the utility for testing, and this company is now worth more than 4 million. Just the perception of what the money that this is going to bring. So it's doing them some very good things. We designed a brand new sensor, a sensing, ultra sensing system that goes into it. And this was by an accident, actually. We're going to buy it from one company and then embed it into our system. But it became too expensive, and we thought, can we do it in-house? So we got someone, and we looked at ultrasonic sensing to sense the water and sense some things about the water. That is working. With that, we were able to look at the frequency domain, event recognition, and many other things that we're able to do, which is now giving us the pressure of the water. It's giving us the tampering. If you tamper with the meter, we know if there's anything going on in the network. And we're beginning to use some machine learning and artificial intelligence. That's the next phase of the project, to detect leakages, which was nothing, it has nothing to do with this project before. But because of the fact that it's smart and there's connectivity, the advantage of the connectivity going to central server means you can do a lot with the data that you have. This was just on the 22nd of December. The minister, this guy is the Minister of Innovation in the UK. He visited our university, and this project was showcased as a major project that is impacting the community in the area. That's the Vice Chancellor of the university, and that's the Head of Research. So I was kind of showcasing, so this is the product now. This is what we are going to start selling in the next couple of months to them. On top of that, we now got a new contract to kind of start sensing chlorine, chemicals, and everything, and be able to through the same pipe. And also, if several pipes are in the same area, we can kind of use algorithm to gather data from different pipes and make sense of whatever we want in the paper from the pipe. So that's about that. I just put that in for some of us that may have our research in a particular area, but actually that research can find a home in another area where it actually makes more impact than the specific area that you are talking about. That's one lesson learned for me personally. This is another project that, again, this is very straightforward because this is my bread and butter. I got a grant with a company, an LED company, and the power line embedded modem system company, and the job was for us to kind of create a tiny module that can go into LED so that you can kind of control every LEDs automatically. So we did that project, very, very successful. That was the prototype, which we kind of deploy at the end of the project. As we speak, they are beginning to kind of, so they've made this, miniaturized this into something very tiny, which goes into every light bulbs and sensors in the building. Again, very, very successful project. It was about 2.5 years, sponsored by, this is the UK #1 grant award committee. It's called EPSRC. They funded me, but Innovate UK funded the business. So that won our award as one of the best.
So are they manufacturing it now, or?
Yes, yes.
So they're gonna put it, yeah.
Exactly. So this company is manufacturing it now.
You're using PLC?
PLC, but the company was using, they had something before, but they were using wireless. So they now use PLC, and they use it for the sensor, they use it for data gathering, and yes, yeah. Next one is this big project. It's a 10 million pounds actually given to Manchester. I'll tell you why they gave it to us, but they gave it to us specifically. It's the project called City Verve, which is IoT for Smart City project. The aim is that you connect everything possible together using disparate connectivity, wireless, name it. So Cisco, it was less because it was given by the Department of Digital Culture and Media, so only the government agency can lead it. I don't know if they are here, but it's, Manchester City Council. The Council of Manchester was the lead, but they're just official lead. The actual lead is Cisco, so Cisco, they led it. But it's a match-funded project, so for me, I got my money 100%, but Cisco has to put 50% of their money for government to know that they are serious. Siemens, BT, these are the big guys in this project, so we did it for 2 years. Very, very complicated project, I think, because the number of people involved are just too many. And I think they made a mistake in writing the bid because you have 20-something partners, but the time is only 2 years. So we spent the first year fighting and the last year before you actually start the work, and then the project was just about to finish. Again, we gained a lot of experience in that. In my case, for example, even though I'm wireless and power line, I specifically decided to do power line because I just finished the other project at that time and I had a lab that I wanted to equip. So they gave me money that I used for equipping everything in the building is basically power lines, all syncing, all dancing, power line. And because Cisco was involved anyway, I couldn't compete with Cisco. So any wireless that I wanted to do, Cisco will do 20 times better. So I just went to something and then we collaborated together. And I think myself and Harris, as a result, we did something extra on top of that with Nokia. So the project itself is 16 million. It's 10 million that we're given, but we had to go look for 6 million. So it's 16 million, 21 partners, and it was involved transport, car park, street lights, building, everything and everything. And why did we get it? Actually, we got that project because we already have this project. So this is the first smart city project that was awarded by EU. Let me go. So these are the partners involved, 23 partners of us are part of it. It's called Triangulum because there are 3 cities involved. It's called Triangulum because it has to do with dissemination, replication, and demonstration. So we are meant to demonstrate smart city in a local area in 3 different cities. So you demonstrate it, that's the demonstration. Then you disseminate it, that's what I'm doing now, go about, talk about it. And then replicate it. So we have 3 cities, Leipzig, Prague, and 1 other cities. They are following us, they are called follower cities. So every meeting that we do, everywhere we go, they see what we are doing so that they can duplicate, replicate whatever that we achieve. So in summary, this is the project. So it's in Manchester, it's on Oxford Road. I will show you Oxford Road in a few minutes. Actually, it's part of 80 billion pounds that was given by European Union, specifically for smart city. There are 19 of them that competed that particular year, but 3 was awarded. We're one of the first 3 that was awarded, and they gave us 28 billion. Sorry, 28 million. Sorry, that's not, that B was a mistake. I wish.
You wish. I was just gonna say.
And then there are 3 cities involved, there are 3 follower cities, and there are 3 things that we really want to achieve: energy, mobility, and ICT. So how can we bring energy, mobility, and ICTs, the cross-cutting? One city council, and we have 2 universities, my university and University of Manchester. And these are the stuff that we want to achieve. I will show you later. Microgrid controller, virtual power plant with some Siemens solutions, storage, network topology analysis, and the rest. So we started 4 years ago. It's a 5-year project. So the first 3 years project was supposed to be installation, connectivity, and all that. And then you use 2 years, the last 2 years, for impact assessment. So prior to the project, we kind of assess this building, that car, all the things that we are connecting together. How do they behave right now? And what is their impact in the environment in terms of CO2 emission? And 5 years after all the installation and we start using them, we compare again and then start to analyze the impact. So we are kind of towards the end now. We've done 4 years. We have only 1 year to go. So in Manchester, what we did that was kind of unique was there's a road called Oxford Road. That Oxford Road is called Corridor. Why? Because there are 2 big universities, each of them about 30-something thousand. So it's 80,000 students to university. Then there's this Royal School of Music, one of the #1, top 2, top 3 school of music in the UK. It's on the same street. At the end of the street is a massive teaching hospital with doctors and trainers and so on. And then the city center is at the other end, the city council. So what we did first and foremost is we converted the whole of the street. As you can see, no car, it's only buses and bicycle. And then we selected a few buildings on the street that are kind of connected together, and we did impact assessment, benchmarking at the beginning, and so on. So yeah, that's what I mean. So that's the Oxford Road. It's called the Corridor, and you have all the major buildings of the universities, 2 universities on the same road. So it was easy to use it as a test bed or a demonstration site. So that's the building of the City Council. One of them that was this is the Art Gallery of Manchester, and that's a very old building from University of Manchester. University of Manchester was established 1820 something. So one of the very old building was that one, and they selected new building, very old, middle, and so on. And then we bought electric vehicles. So I bought 2 Nissan Leaf, and we have 21 electric vehicles already on that corridor, which we use for various things. Manchester University bought 5, I think. Is it 5 or 7? It's 7. So we actually have the same money, but I use my money to buy, and they use their money to lease instead. So they lease it for 5 years, I bought mine forever. So because we already have 21 at that time, my university had 21, but they didn't have, so they basically lease it. So we then have, telematics on all the cars, connected everything all together, and yeah. Next thing is that we have bikes, and they are all electric bikes, cargo bikes for distributing stationaries, newspapers, and so on, and some bikes for students and staff. Okay, they are all connected. They are all electric bikes, actually, all part of this. So the money here was a bit difficult. Should I buy the bike? Should we have, what do we do? So we just use the money that we have from the commission. We gave it to a company, and we kind of not lease. We rented it from them, and we gave it to people for free for the testing. Okay, so that's that about mobility and about the building and energy. So what I work with Siemens is actually this. It's called central controller. The role of the central controller is to connect everything possible, all these energy resources, solar panel, wind turbine, everything, combined heat pump. They connected it to this central system. And that system has a link to exchange rate, a link to market, a link to economics, to some weather condition and some data. And that's why it's called virtual power plant. So even though it's not a real power plant, it has capacity to connect all the plants together and then give you information about the plant. So ultimately, what we ended up creating is something called Manchester Eye. In Manchester Eye is a repository, like a database, where all the data about each of these buildings go every 5 minutes or whatever we set it to. There's also information about transport, and we're able to also link it up to every agency. Some agencies in Manchester, they give free data into this platform, and the platform is open to anyone. Now, it's at this point, I think it's important to mention that the first 1 or 2, actually 2 years was very, very, very difficult, because it seems nobody really knew where the project was going. Again, because of the number of partners, again, because of the complexity, and I think people underestimated some of the things that we promised. So for example, there's the ontology of the paper, of the data. So when you say data is coming from building, about energy, data is coming from electric bikes, it's coming from cars, and so you need all of them to kind of look alike, to be speaking the same language. That took a lot of time, even though it looks very simple. So we now have, like, we use OC software. That's what we use in Manchester Eye. So at the moment now, students are now actually using it to develop app as part of their project. People on the street can develop apps based on big data on that platform to do whatever they want. The advantage of this is actually that people are now developing proposals with us. So with Austria, for example, I was in Russia the other time, we were talking about it, is because we already have this platform, and I think this is what EU actually wanted to do, that you have the platform now. People that want to do research on top of that don't have to start from the scratch, which costs 20-something million. All right, they can just use your data and if you add a few things to it. And that is why we were given the 10 million from IoT Smart City, because we already have some of this platform. They thought, all right, if we give you money to do something, you don't have to ask money for all those ones, you just ask money for what you want to do. And we're able to kind of use like complementary. Now, this is a building which is dear to my heart. This is actually my own. So out of the whole project, this is the building that I control, because it's based in my school, my faculty. So it's brand new and so on. So it's Brooks Building. Now, because of the project, this project and the innovation that we added to this project, it actually won the best building of the year, 2018 in December. So Siemens, that's the director, a senior director in Siemens. So, and some of us were in London where we won. It's called Public Building Energy Project of the Year in Energy 20, because of the virtual power plant and innovation that we brought into that building. What is kind of unique for it from research perspective about this building? See, this is the building here. So you have, I think, a multiple of maybe 5,000 or so students. They are here. There are 2 faculties, really large, 2 faculties there. We equip from this project. We kind of have solar panel on top of everywhere on top of the building. What is also good about it is that this building has student hostels all around it. And next to the building, somewhere at this side, is what we call energy center. So that's inside the energy center. You have combined heat pump, you have underground heating, we generate our own water, and that building you can disconnect it from the grid, and you will still be able to carry on without the grid, and you can sell back to the grid as well. So we have that. Then this is a battery we bought. This one is just about 2 months or a few months old. But it's £600,000. We bought this battery. It's really huge. So we're using this battery to work with the solar panel.
Explosives.
Yeah?
No, I'm just joking. I'm thinking 520 kilowatt hours of battery. That's a massive explosion.
Explosion. Yeah. So this is actually part of the challenge we're having with this battery is that for several months it was installed. It didn't work because for safety, because there's only 1 or 2 people they know that will operate it.
I can see this as a massive danger.
Yeah, it's really big. And so this is what you have here, heat pump and so on. And then next to it we have a car park. And everything is within this building. And in this car park we have electric vehicles that are parked there. And so we can kind of do demand response. Get electricity from the solar panel, store it if we have to store it, go into electric vehicle, and all these things are going on. And the fact that they are all connected to this central server, and also the fact that from this central server called virtual power plant, you can actually turn things off and on as you wish. Again, that took several months, several meetings just to know what to switch on, because I, as a researcher, I'm interested, but the estate guy says, look, student pays £19,000. You can't just switch off the lights and so conversation. And when the European Commission actually came for one of our reviews, we were trying to explain this, but not in detail. They were really keen about it. They wanted to write it in detail because that's the reason we didn't give you money to be successful, if you like. We gave you money so that any mistake that you make become part of our record, and we can pass it down to other people. So that kind of gladdens our heart, and we started writing every detail of whatever we did. So as a result of the uniqueness of this building and all this that I've said, and the fact that we have thousands of students around, you have staff, you have people with different behavior, we've started to use that data for what I call gamification of energy. So gamification of energy is how can we incentivize the students, the staff, to use energy in a particular way. Is there any way using the virtual power plant that we can actually know that come tomorrow, electricity will be this much, and we can discourage you from consuming energy at that time and encourage you to do it now? Or we can say, okay, at this moment, don't consume now, do this tomorrow, because we have virtual power plant that is telling us everything about all the energy, and it's telling us, then we have the weather condition, we have the price, we have all this stuff. We can then use them because they are all connected together. So we've done initial, we have a PhD student that is actually looking at that, and this is not even pure science. I employ her from geography, environmental sciences. She's looking at the impact case study. So she's looked at some various ways of doing gamification. So we now turn that building, what we call it a living lab now, because it's like a living lab where all things are kind of
so students do not pay bills, but they can lose the power at any point in time?
No, what we did is we actually checked with students. If you say to a set of students, pay your bill at the beginning of the year, it's part of the fees. How do they behave? Some of these things we might say we know how do we behave anyway, but there's no objectivity to it.
Sure.
So we've been able to objectively see how they will behave. When you ask them to pay monthly, and when you have to them pay at their school fee. When you incentivize them to say, okay, here is £5. If you reduce your electricity consumption, I'll give you £5. Or we give them pizza. What will happen with pizza actually change your mind. And also, if there are people on the same building, like block, all right, and there's a guy who reduced his energy by 50% last month, would that actually make you to think about maybe not wasting energy anymore? That's what gamification is doing. And what is good about this is actually, I have like a postdoc, his core area is gamification, algorithm, really serious calculation, and some complicated stuff. And we are beginning to see how the real gamification algorithm can marry with reality as well. So we bring it to fuse, using this living lab, we are now bringing together fundamental science, which is just algorithm and publishing paper in the past, to something that is a bit more realistic.
So did you really give the pizzas?
Yeah, we get 5. I remember we did the £5. Yeah, the £5 voucher.
How was the outcome?
Of course, £5 makes you to think.
Yeah?
You see, with what I realize is that even I kind of reflected, is it because they don't have money? I don't think it's because of the £5. It's just because of that game, and you are just applying human nature, natural human instinct, human behavior to something that we already know. So some people do game not because they want to they even lose money, but they are happy. It gives them satisfaction. So in this case, it actually makes the student to do better. Yeah. And what we want to do next is we develop an app with a small company called Triangulum. So we want to do this now via app. So you download the app, you have it with you right from the beginning of the semester, and you can see the energy consumption by yourself and by people on the same block, and you know who is the best guy, and there's maybe a reward for the best guy. And the best guy becomes like a celebrity, if you like. You know, you make it look.
So, you know, we are actually going to play the game. Jorge is going to play the game with this build.
Yeah, yeah.
And I'm just letting all of you know that we're going to start playing with air conditioning system. And you will have to vote whether you like it or not.
Yeah, yeah.
Are you cold? Are you hot? That kind of stuff.
Yeah,
It's always
yeah.
cold in the
There you go. So you see, we'll play with that. But you know, it's a similar,
similar
type
thing. You know, so we use app.
So who is charging the costs for the energy? Is that the university?
University.
So not the government?
No, it's
not the
university.
utility.
Yeah,
It's
no,
university who's
it's
charging
us.
students.
It's students, yes.
You're hosting the students and then charging them.
Yeah, because they
money.
pay it as part of their rent. Yes.
Huh.
Yeah.
So,
Maybe I should
Good-
start
good
charging
strategy,
for a
yeah.
while.
Yeah.
No?
That's
So-
got a chance.
Right?
Yeah, sure.
They complain when we do denial of service on wireless, they all complain immediately. You can hear it immediately.
Yeah. Well, actually, we're talking about students. Let me just give you another thing that we've done that is, you know, very useful. Like I showed you earlier, that some of these buildings are very old, so you actually need to preheat them. So if before staff comes in at 9 a.m., you heat them 2 a.m. Yeah, for 2 hours. I don't know why, but they seem to have done this forever. They preheat them 2 hours, yeah, and then wait. Then about 2 hours before people start coming, they start heating them. All right, and then we use this virtual power plant. It's not controlled by us to say, okay, let's see what will happen. Heat it 1 hour in the night and 1 hour before. All right, and no one complained. You know, given the same kind of weather condition and the rest. And then we reduce it to 30, and then people start feeling, so they put on their coat and jacket, but it didn't result in so much complaint. Then we just increase it like 45
you
minutes.
just decrease the temperature and then see how it is.
That's what we are planning to
Just
do in this
start-
building.
Yeah.
Start decreasing until somebody gets frozen. Huh?
Yeah, but you see, what it tells you is that that's human. At the end of the day, we want the room to be warm, and if you are really sincerely asked why, you say it's because of human. Okay? If the human is then feeling uncomfortable because you are trying to make them happy, then you've actually paid a lot of money to cause somebody discomfort. Does that make sense? So, but with this smart technology and connectivity, we're actually able to objectively know how this impacts on people and save money as a result of that. Yeah.
Are you charging different amount? Are you including the fact that electricity is a different value at different times?
Actually, that is the motivation, is at the very heart of this, is that in my university, it is 4 times the price from 4 p.m. So 4 p.m. on, and it stopped at 7, it's not even for too long, so it's 4 to about 8 p.m., 4 hours. It's 4 times the price. Whatever you pay 3.30, you pay 4 times. And what are we doing with that? How are we saving money? Simple, we just put all that to my electric vehicle, charge it. Put all that to this battery, and later we take it back to the grid. So we actually completely shave it off. Yeah, does that make sense?
Yeah, sure.
Yeah. So I mean, it's very simple, but that's what we're doing. Now, don't want to take too much of your time, but you see, Mackenzie brought this report out last year. How did I know? I'm teaching a unit at MSc level. It's called Smart Technology for Energy Management. So when this report came out, 2007 December, it's just 1 year plus old. This. I kind of read the whole report, you know, about the energy between now and 2050. I would recommend if you want to read this for the people who are interested in energy and electric vehicle in particular. But what it came up to is that, you see, building in terms of energy usage in building, we go from 31% to 43%. But look at this, transport, electrification of vehicle, we are currently consuming less than 1% of electricity. But come 2050, it will increase to 20% of electricity consumption will be coming from transportation. But actually, that is if then industry will be this. But that is if it's just normal. If we bring disruption into electric vehicle, and what do I mean by disruption? We all know what disruptive technology is. If electric vehicle becomes disruptive, Okay? And how can electric vehicle become disruptive? It's just the way our mobile phone, my example to my student always is that my granddad in Nigeria, when you went into his room, sitting room when I was growing up, you will see a big calendar. Yeah? And that calendar, we tell him his birthday of his grandson, the whatever and so on. Yeah, that's what he was using his calendar for. You go into his room, there's an alarm for him to wake up early in the morning or things like that. Things like that he has in his life. Today, all right, one thing can do all of that. Calendar, telephone, and so on. I joked that I even saw a lady using it as a mirror the other time. Yeah? You know, using mobile phone as a mirror for makeup, yeah? So what does that tell us? It tells us that one device that is doing so many things becomes disruptive and you have to have it. Can electric vehicle be like that? I think the fact is it can. If electric vehicle, we have a new business model we're working on, actually that it becomes not just a storage for you, but it's actually something that you buy a car, but you do not own the battery. So you guys, you don't pay for the car. Somebody pays for the car, but on the condition that they own the battery and they can use the battery for whatever they want. I was at a conference, I think with you actually, some times ago, and there was this presentation about what autonomous vehicles is going to do in the future. Because for a car to be autonomous, the computing power needs to be 4 times, if not more, than the servers that we have currently. So, but remember, cars are parked 90% of the time. So it means if you have a car that has computing power that is 4 times the server in order for it to operate, and it's like that 90% of the time, what can we do with that memory? What can we do with that data crunching capability of the computing system inside the car? So that means a car is no longer just a car. An electric vehicle becomes infrastructure, a storage infrastructure, a data analytic infrastructure, a computing infrastructure, and so on, all right? So if we begin to buy cars, not because we want to drive, but we buy it because we want to use it as part of our infrastructure, it becomes disruptive, which means this might even be more than 20% if you go up and up, right? And as a result of that, the next research
But that energy is not all used for transportation. They're using the
For computing, for
it's
storage,
using for everything else.
yeah.
So back on your growth in electricity there,
Yeah.
I suspect that most of that electricity usage is cooling and transportation.
Yes, actually cooling and heating is about 80%.
Heating or using heat pumps?
So yeah, heat pump
Okay.
or any space, cooling or heating of a space plus cooling and heating of water account for several percent of consumption. Very high. But if that's now. I think in the future, what is we actually seeing is that all these things, consumption are going to come down a little bit in some areas. The reason is because we are looking for efficiency, we now have services, we now have new technologies. However, in terms of transportation, electrification of vehicle, everything will go up as a result of electric vehicle, not just cars actually, but train, trams, and the rest, trucks. And with disruptiveness, then we have even more. And that takes me to the next research that we're currently working on. It's called V2G, which is basically, so that's that project is basically how, so what we have at the moment, there are cars that we just charge and people can drive them away. But what will change the game in the next few years, and I think it started gradually now, is when you then park your car and you give rights to anyone, well, to a company, that they can go into your car while you are not there and sell the battery, the charged battery to somebody else. And that goes back to your question, sir, about at 4 p.m., what do I do with those batteries? So not just one. So these are millions of cars, and because we have connectivity, they are all integrated. That means we now have a virtual electricity based on this electric vehicle, which we can say, instead of turning on a new generator or increasing energy supply at that time, we don't increase energy supply, and we don't reduce demand actually. Yeah, demand is still high. Then all we just need to do is to take batteries to augment that.
But you will keep the demand in the moment when a couple of billions of people enter the car at the same moment and start charging it, right?
No, no. Aha, that's good. The reason why you don't do that is that cars naturally, just we've parked your cars, you know, for since we came in the morning, and maybe you just go and it's all charged, and you can then say, I need charge rapid. I need to charge not rapid. Not rapid means in the next 9 hours, I'm not going to go to that car anyway. Just charge when nobody else is charging, and charge me from the roof, you know, from solar panel, from the wind, and graphene is coming. Graphene is going to change it.
What I mean is, for example, if you have this 1 million of connected cars, you absorb the energy and accumulate it in some other demand that is currently needed, but those batteries will go down, right? I mean,
yeah, but the assumption is that you have excess capacity, right?
Yeah,
In other words, you're not going to spend your, if you, let's say, you start at 4 o'clock discharging, and at 5 you walk into your car and drive.
Right.
Assumption is you're not going to use 100% of your battery. Right?
Plus,
or go home.
You will actually set your car to say, well, this is my tolerance.
Exactly.
After 60%, I don't want to sell anymore. And even if the price is not this high, don't sell.
Yeah,
and for £5 for pizza.
So there's a limit up to which you don't deplete the battery. And then he comes empty.
Exactly.
Yeah.
Or if there is a pizza.
Exactly.
Pizza,
and by the way,
it might be it's better deal than the £5.
And by the way, there might be a deal that you actually sign a contract, with the guy who buys. Remember, it's not your car. It might not be your car. You understand? It might just be that I have given you a car, but I own the battery. So actually, I'm the one controlling the car. So it could be that I say, well, part of the condition for this car is that at this time of the evening, maybe you can't drive the car. It could be anything. So we're working on that. Actually, this is the model we are looking at. So we've looked at the classification of different vehicles. So we are working with Manchester Airport on this. So we're looking at different vehicles, different building, different human behavior, and with connectivity, we're able to bring everybody together. And by the way, there's something that you need to remember. We are not dealing with cars. We are dealing with virtual power plants. So what we develop is not, it doesn't know whether it's car that gives you the power. What it knows is that at this end you have 100 megawatts, 10 megawatts, it doesn't matter. So it could be combine of cars plus what, even if the car just drives away, it just drops the value of that car from the virtual power plant. But at this end of the virtual power plant, you will see the 10 megawatts or whatever. So as a result of all this virtual power plant is controlling everything, but actually the main thing is we want to do two things. Change behavior, create a new business model that incentivizes the use of electric vehicle. I'm kind of rounding up, just to let you know. I think this is the last one, so this may be the last thing I will talk about. So this is the project I got 2 years ago with Oxford University, Imperial Bath, and 5 South Korean companies. Now, what we're doing is called peer-to-peer energy trading. So now that we have all this platform, can we turn everybody involved, every actor involved as a prosumer? So you consume and produce electricity. So the guy who is charging from his car is actually a consumer in 1 minute, but an hour after could be a producer because he's selling the electricity from his battery. So every actor within this become a prosumer. You're consuming, you are producing. But at the moment you have to sell through a central organization. So can we do Airbnb for electricity? Instead of me going to a hotel or going to, can I get the house that I want and I don't have a central server and I know I'm dealing with the owner of the home or something like that. That is what this is planning to do. We've worked on it for more than a year and a half, going to 2 years now. So we have about 3 companies from South Korea, 2 universities, and the rest guys are from. We've been able to do it. We've developed various algorithms, different gamification, blockchain. They are looking at different aspect of this. So my own role basically is to look at communication architecture that brings all this together and where the blockchain kind of fits in, different things fits in. And I have a PhD student who is kind of a postdoc as well, who is looking at each of the prosumer. If they have to remember, if I want to sell something. So I say, well, I'm going on holiday and I have 2 weeks I'm not going to be home. My solar panel, I'm not going to take it off. My car is packed. So car can actually deal with the solar panel, store it during the afternoon, and in the night I'm not using it, so the car is useless as well. Can I sell it to my neighbor? Yes. But do I have to go through central service? No. I want to sell it only to my neighbor, not to just anybody else, right? How do I do that? So it's this platform that is going to do it. And for how much? For how trade? That's the whole idea. But in communication system, 5-10 people might be fighting over who buys this electricity because of the price at which I want to sell it. All right? That decision needs to be made based on latency of the communication network and all that, capacity of the system. So we're looking at various ways of looking at prosumers. So if you have 5 prosumers and they are all trying to compete, how long will it take? If you have 15 prosumers, if you have 20 in a microgrid. So that's the kind of work we're looking at now. And somebody's looking at actually gamification aspect of it. If we're doing gaming and all this gaming, there's actually an aspect of it that requires connectivity, and we have to make decisions as to how much does it cost in terms of connectivity. So it's really the work is interesting because it's a marriage between electric distribution network in itself, but the core of it is the connectivity and data analytics that helps you to make decisions, and you're able to feed back into it. So yeah. We have a few published works out there if you're interested. But yeah, that's it from me.
Thank you very much.